Yeah, very good morning to all. So in this session we are going to see one more form of green energy source in generation of power, which is magneto hydrodynamic energy. Introduction. Magneto hydrodynamic system is a non-conventional source of energy. Non-conventional source means it comes under renewable energy resources, just for consideration, based upon Faraday's law of electromagnetic induction, which states that the energy is generated due to movement of electric conductor inside a magnetic field. So we will see what is Faraday says. So in a Faraday says, there are three forces that should act perpendicular to each other. The three forces are: one should be from north pole to south pole, which is nothing but your magnetic field. Another one, to this you should move conductor in perpendicular to the magnetic field. So in the third direction you will have a generation of electron or flow of electron, or we call it as power generation. So when you see this diagram, I am going to have an anode and a cathode, this two surface, ashed surface. So this ash surface I am going to make it ready for the electron which is going to be generated, which is to be taken out. So for this I should have a two person perpendicular to each other. One is the flow of conducting gas, that is the key point in hydrodynamic, magneto hydrodynamic. I will tell what is that gas which is going to flow. And on the top and bottom we will have the magnetic field. So you can see here applied field. Applied field is nothing but magnetic field. This is in perpendicular with the flow of gas. So this is perpendicular to this. On the third direction you will get the power. You can even understand it clear when you see in this diagram. So you can see here, this is 2R. Either it can be solenoid, which means electromagnet, or a permanent magnet. Nowadays we get permanent magnet with high magnetic field you can use, or if you want you can go for solenoid, but for solenoid I need power. Okay, so again we have to see whether that power is green power or whatever. So instead you can use a permanent magnet. So on one particular direction there will be flow of magnetic field. So this is the direction of magnetic field. Okay, now this is, you have to make the gas, conducting gas, to flow perpendicular to this magnetic field, and that is this particular V. So when you apply this 2, then there will be a third person which is being generated, which is I, which is nothing but current. So that we will tap from this two surface. You can see a top surface here and bottom is invisible. So here we will place cathode and anode and we try to take. This type of power generation was started in other countries, and in India it is under construction. So let us see here again. From this direction only I am going to send the working fluid, which is called as plasma. What is this plasma? Is nothing but gas in conducting state. Normally we all know gas is an insulator, which means it doesn't allow current. Now we have to make something that you have to make this gas as a conductor. How to make a gas as a conductor? Which means you have to ionize the gas. So if you ionize the gas, then the gas which is going to flow from this end to this end, which is, you will have movement, and that gas is considered as a moving conductor inside the magnetic field. So this is the magnetic field, and this is the direction which is the gas is going to flow. And since this is a conducting gas, that is going to act perpendicular to the magnetic field. That's all. You have generated the two component. Third will be automatically the flow of electron. You will generate the power. So now to understand it more clear, what is that called as working fluid or plasma, which is nothing but conducting gas. I have told you how to make a gas conducting. Very easy, simple method. Heat the gas. When you try to heat the gas, it will become conductor. Now where should I go and get the gas get heated? It is again simple. You do any other combustion, what will be the resultant? Heat will be generated. That heat you will try to leave it to the atmosphere. Now we are saying don't leave it to atmosphere. Now that heated air, try to bring here and pass it across this. So some waste obtained by some other process is being taken here, brought here, and try to utilize it and generate power. So that is why we call it as a green energy way. So this is again just a Faraday's say. You take your right hand, you will take 3 fingers, each pointing perpendicular to each other, and thereby you will generate electricity. Okay. Now comparison between a normal hydro generation and our MHD generation. In normal, what we do, we have a north pole, we have a south pole. Centrally we place conductor. What is the procedure to generate electricity? This conductor has to move. So to move this conductor, what we will do, we will add a structure like this. We call it as a turbine. When hot gas or steam is passing over this, it starts to rotate. When this is rotating, you get a rotating conductor. So whenever magnetic lines of force are cut by a coil, an EMF is induced, where you use a brush and try to tap it from this rotating fellow. This is a normal turbo generator. Whereas when you come here, see, somewhere I might have used the gas for heating. You see, in all process, when you go for an iron and steel industry, I will try to melt the ore and I will try to get copper, or I will try to get iron, or I try to get steel, whatever may be. It is a type of, depending upon the type of ore we are going to take and resultant product. Now what you will do, you will heat and try to melt it and molten it and try to get it. At that time you might have generated very hot air. Now what we say, don't waste this hot air, bring that hot air and try to pass it here. So when you try to pass it here, that hot air will become a conductor, and when the conductor is moving, see here you have made a conductor with the help of wires and a solid copper that is being rotated by this turbine, whereas here the air is going to move from this end and this end. So which means you are having a moving conductor like structure. So that's all, that is what we required. So north pole, south pole, you have kept it. You are going to pass the gas here. On this two end you will try to generate power. That is the how what is being followed in MHD generator. So here when you go for MHD generator, there are a type called open loop system and a closed loop system. We will say what is open loop and what is closed loop system. So initially we started with open loop. Again I will say you are getting heat as a byproduct of your process, where you are going to heat the ore or any other way by which you are getting heat as an output. That heat we are not going to leave to atmosphere, rather I will take that heat and try to heat my air and make my air as ionized. Okay, ionized air, then bring it here. Nozzle is nothing but to increase the pressure, that's all. To increase the pressure is to make air flow at very high pressure here, then only gas will move at very faster. So I will have a nozzle. Now this is the structure. You can see magnets are placed. You are going to move your gas through this. Automatically what happens, due to Faraday's law, you are having magnetic lines of force cut by a coil. Instead of coil here it is gas, therefore you will get an output. That output will be taken, if it will be DC output, by using an inverter I can convert DC into AC and use it for our application. So when you say open loop, that this air coming out of our generator will go for preheater. Preheater means it will have even some more heat. That heat we can try to tap it. That heat we will tap it by taking an inlet air and try to heat it and bring it to our input side. Next is the remaining air where heat is removed is being sent to seed recovery. And finally seed recovery is nothing but if there is any other particle which is harmful to the atmosphere, because the gas is not purely manufactured for our purpose, it is being used by some other process. So during this process, not only heat, some gases might also be released. That gas should not be directly given to the atmosphere. You have to put a filter and observe. All this act as a filter, then finally we leave. Now you can see what is open loop is. You have taken the air, use it for power generation, and some heat is been left out. That left out heat is being used, and the remaining is sent to atmosphere. So this air is again not being reused. Once it comes, it passes and it finally goes to atmosphere. That is why we call it as open loop. So what will be the difference in closed loop? You try to bring this fellow again here, so that we call it as open loop, closed loop. So in closed loop, before going into closed loop, there is an hybrid method. Hybrid method is utilizing for more than one purpose. So what I am doing here, I have kept my generation, that is MHD generation. I am even getting some heat, even some heat is been left out. That heat is also been tapped, and remaining heat is not been just sent to the cooling tower. I go for steam generation. So this is a non-conventional method. So this is conventional method. This is non-conventional. This is conventional method. Again, heat from the heat you will generate steam, and you will give it to a turbine, where turbine is a rotating part. So this is nothing but, you can see now, the output of this is directly not led to atmosphere. That outlet is being brought here, and it is made to move this. Again I am getting power. So 2 times I will get a power when I go for an hybrid. Hybrid, the word itself says it is more than one. Okay, so initially I got hot air from some other process. That hot air is being used to generate power by MHD, and that let out also will have some amount of heat. That heat I am going to again use for steam generation and generate power, and finally I am leaving it to atmosphere. Since it is an open loop, we should leave it to the atmosphere. But same case when you go to closed loop, you have a reactor where you are going to do some process and try to do your work, and then that work has resulted in heat generation. That is being brought here, used nozzle to compress, then that compressed gas is sent to our MHD. Again you can see that output is being brought here and made as an heat exchanger column. So this material is not a normal gas. This is not a normal gas. So this is nothing but a potassium liquid. So why we go for this closed loop with potassium liquid, we will see when we do comparison. So in previous case, just gas which is coming out is being used, but now what we will do, that gas heat is being transferred to the potassium liquid, and the potassium heat gets eaten up, and that is being brought here. So this potassium again it will be brought here, it will get the heat from the reactor, again it will be brought, and this person is not allowed to leave out. This is circulating inside this process. Okay, that is why we call it as closed loop. Okay, now we will see the comparison. So in open loop, working fluid after generating electrical energy is discharged to atmosphere through a stack. So you are letting the air to go out, whereas here working fluid is recycled to heat source, and thus it's used again and again. So why we want to use again and again, that we will see here. See, the operation of MHD generator is done directly on combustion product. So you from some other combustion product I try to get the gas. Now here the combustion process where heat is being absorbed by helium, argon, or whatever we see in on last slide is for potassium. So we are trying to heat this fellow, and this fellow is being brought inside your MHD. So the reason why we are using these fellows are, these fellows are easily converted into ionized state at a lower temperature. So when you take a normal air, so that requires 2700 degree to get it into ionized air. So you take a air, when you constantly heat this air, when this air will become conductor at 2700 degree, whereas when you take helium or argon at just 530 degree itself, they will get ionized. So think here, the reactor, if it is heat is around 700 degree itself is more than sufficient for my MHD, or if normal gas is taken, you should have a heat of 2700. So that is the where we go for closed loop. Insufficient amount of heat is present, not more amount of heat is not there. In that case, you go for closed loop, you use an additional gas, that gas will get eaten up and it will come to conductor state at a lesser degree itself. Okay, more are developed based upon open loop system, less developed in country like India. We are in research and we will try to bring it to real world with a closed loop system. Okay, conclusion, the MHD power generation is advanced stage today and closer to commercial utilization. Significant process is being made in developing such technology. Coal burning MHD combustion steam power plant promise a significant economic and environment. So that is what our conclusion. So you can install our MHD in the existing thermal power station. In existing thermal power, like for an example, in Tamil Nadu we have Neyveli. In Neyveli Lignite Power Corporation, what you are doing? Taking the coal, burning the coal, from there you try to generate power. After generating, you will have enormous amount of heat generated. That heat is being used by this MHD to again generate a power. That is what this MHD is. It will not be longer before technology problem of MHD and will be overcome the MHD system without transformerless and conventional way of energy generation. So what we are, this process is in research. On one fine day or within few years we will install this MHD in all coal thermal burning power station. Okay, thank you. If you have any queries or if you want to ask any questions, you can always comment it on my YouTube channel. Thank you.